So today we're going to be running through how to use the ArmSense EMG sensor device. Firstly, we need to power on the device, so we're going to plug the battery into the controller module. From there, we're going to power on the device, and as we can see here, there's a red LED indicator showing that the device is on but not paired yet. So now we go to our UI and we hit Find Devices, which will search for all ArmSense devices. And as we can see, ArmSense pops up, so we select it and hit Pair Device. And right away, we can see that the LED indicator on the armband turns green, showing that it's paired, and also the raw EMG data is now being read in as seen on the UI. So now we can place the device on the forearm with the controller module facing up. And as you can see, with basic fluctuations, we do see the EMG signals changing. So now we'll run through a data collection phase. This is used to expand our data set over time to train a better model. So as you can see, when we hit train data, firstly, it brings the new user to a resting position to calibrate the sensors. So here, it will go for 20 seconds, measuring their EMG signals and storing this data into our data set. Now, after this, we will go through the 4 actual gestures, which are fist, peace, point, and thumbs up. Each gesture will be performed for 20 seconds total in 10 repetitions of 2 seconds each, where the user contracts for 2 seconds, rests for 2 seconds, then waits for the next repetition. During this process, like I mentioned, we are collecting the EMG signals, and we will store all this data into our data set, where the features are automatically extracted during the real-time sensing. So now that data collection is done, we can go ahead and train our new model. Now, since we only collected one set of user data, this should be relatively fast for the sake of the demo. So if we hit the train model button, we will see it train and we get a notification saying it was successful. So from there, we can actually go into evaluation mode, where we will actually predict the gestures based on real-time data, as we can see when we click this button here. Now, on the evaluation page, we can see that as we move our hand to do different gestures, that is pictured on the right here on the UI, where it says the gesture prediction as well as a picture of where it is. Additionally, we can see that the gesture prediction is actually carried out on the robotic prosthetic hand on the left. Now, as you may be able to tell, gesture predictions are pretty poor. Even though our trained model was above 90% for accuracy, our live predictions are only reaching around 56% accuracy. The main reason for this is because of electrode shifts. Now, since we're using dry metal electrodes on our armband, it has a tendency to slip while in motion, and because of this, it loses its original position compared to where it was calibrated. Something else we noticed was that over 50% of our misclassifications occurred where gestures were too similar. For example, whenever we have a fist or thumbs up gesture, they often get misclassified as each other. Additionally, when we have a point or peace gesture, these often get misclassified as each other as well. Now, once we're all done predicting, we can hit the home button to return back to the home menu, and then we can disconnect from the device by hitting the disconnect button.